In our previous graphs, we've always assumed that voting occurs along a single-dimensional issue, something like public spending on a local public good. But often voting occurs along multiple dimensions. Consider, for instance, the case where we vote in a congressional committee or in an election on two issues: domestic spending and military spending. In this graph, we'll illustrate how we can draw preferences for voters in the case where there are two-dimensional issue spaces. We'll plot the issue Y on the horizontal and the issue Z on the vertical, and we'll only consider voter tastes that are single-peaked within these two dimensions. Thus we begin with the voter's most preferred combination of policies, YI star and CI star. The voter will then become worse off as we move away from her ideal point. And if we assume that the only thing that matters is how far away from her ideal point we are, but not which direction, her indifference curves will take on the shape of symmetric circles around her ideal point. The farther the indifference curve gets from her ideal point, the worse off she'll be. So she's worse off on the magenta indifference curve than she is on the small blue indifference curve. And she's worse off on the green than on the magenta, and worse off yet on the larger blue indifference curve. The nice thing about assuming that only distance from the ideal point matters but direction doesn't is that we really never have to draw the indifference curves at all. We simply have to indicate each voter's ideal point, and we know that any distance that we move away from that ideal point, regardless in which direction, will make the consumer worse off, and worse off by the same amount if it's the same distance. In panel B, we now illustrate three voter ideal points: voter 1, voter 2, and voter 3, and a policy A that lies in the center of their ideal points, equally distant from each. If there's any policy that might be a Condorcet winner, a policy that can defeat any other policy in pairwise voting, we might think it's policy A. But I'll propose a policy G, and my claim is that I can design an agenda of pairwise votes that will get these three voters to ultimately choose G over A. We'll prove my claim in graph 28.8, and for now only note that if this is true, then we know that single-peaked preferences by themselves are no longer sufficient for the existence of a Condorcet winner when the issue is two-dimensional rather than one-dimensional.